Hey, and thanks for checking out another video. In this video, I'll show you the steps for formula writing for type 2 ionic compounds. So to get started, when we look at the steps for type 2 compounds, which are compounds that involve transition metals or metals that are bonded to a nonmetal, and the metals have multiple potential charges. So the very first step is to write the symbol and charge for the metal. And the charge is what you see in the Roman numerals in the brackets. The next step is to write the symbol and charge for the nonmetal. And then if the two charges add up to 0, then you're finished writing the formula. But if those two charges do not add up to 0, we do what I taught you in the last formula writing video for type 1 ionic compounds, which is called the crisscross method, and you add those as your subscripts. So let's look down here at an example for formula writing we've got two examples here, iron 2 oxide and iron 3 oxide. So just a reminder, when we're looking at whatever you want to look at, let's look at the metal first. The charge on the metal is given to us in Roman numerals. So this 2 represents the charge of iron. So the very first step that we're going to do is go up and write the symbol and charge for the metal. If we're looking at iron, iron's charge is Fe, and because we're looking at the charge that's written in Roman numerals, this says that iron here is a 2+ charge. Then we're going to write the symbol and charge for the nonmetal, and we're looking at oxide in this first example. So that means our symbol is O for oxygen, and oxygen is in group 16. That means it has a 2- charge. Then we can take our two charges, and we say that 2+ and 2- add together to give us 0. So we know that our formula is complete. It's balanced as we see. So iron 2 oxide, the final formula would be FeO. Now we can also go ahead and look at the next example, iron 3 oxide. So again, we'll follow the same steps that we did before. The very first thing to do is write the symbol out for the metal, which is Fe. And we're writing the charge this time. And notice that when we're looking at the Roman numerals in the brackets, now it is 3. So that stands for the 3+ charge that belongs to iron, because that's the cation. And then we're going to write the oxide out. So that's O, like the last example, 2-, because the anion, or the negative ion, does never, its charge never changes. So in this case, when we look at the charges that we have, 3+ and 2-, those do not balance out. If we were to add them, we wouldn't get 0. So what we're going to do is now we're going to take the superscripts that you see there, or the charges of each atom, and write those as the subscripts. So this now becomes Fe2O3, and that is our final example for the two examples I've given you. Just remember a quick note that the superscripts stand for the charge on the ion to their left, and the subscripts, the thing at the bottom, tells how many atoms are in the compound. Let's check that up here. Fe2, that means there's 2 iron atoms and 3 oxygen atoms in this compound. So I've given you a few examples here. What I want you to do is write the formulas for the following compounds, and I've given you 4 to try. Number 1 is iron 2 sulfide. Number 2 is cobalt 2 nitride. 3 is tin 4 oxide, and number 4 is manganese 2 sulfide. So what I'll do is I will give you a few seconds to pause this video, or just watch right through. I'll give you 10 seconds, and then I'll come back and give you the answers. So let's look at the answers now. For the very first one, iron 2 sulfide, I'm going to write that out as Fe2+, and S has a 2 minus charge. Therefore, the final formula for this iron 2 sulfide compound would be FeS. For the second one, we're looking at cobalt 2 nitride. Cobalt has a symbol of CO. It's got a 2 plus charge in this compound, and nitride has a 3 minus charge. Notice that these are not balanced right now, so we're going to use the crisscross method, and that will give us a final compound of CO3 N2. For example 3, we're looking at tin 4 oxide. So tin has a symbol of Sn. In this example, its charge is 4 plus. Oxide is O2 minus. Those don't balance out right now. So what we need to do is we need to figure out how many oxygen atoms would make that balanced out. You can do this a couple different ways. I will make this T-chart that you see here. And this tells me that I have a 2 minus charge and I have a 4 plus charge. So I'm going to say, what number do I need to multiply 2 minus by to balance out 4 plus? And that would be a coefficient of 2 in this case. So my equation, my formula for tin 4 oxide is going to be SnO2. And we're looking at the last example, manganese 2 sulfide. Manganese is Mn. It has a 2 plus charge in this case. Sulfide is S, and it has a 2 minus charge. So those are going to balance out. So our final formula would be MnS. So there you go. I hope that this video helped. If it did, please be sure to give it a thumbs up and let us know in the comments below video ideas you'd like to see. And please subscribe to the How To Scholar for more how-to videos. Thanks for watching.